So, hello all. Now the topic for coordination compound that we have here is nomenclature of coordination compounds. When I say nomenclature, we obviously mean IUPAC nomenclature. So, nothing to be surprised, it's not organic chemistry, it's coordination compound, complex salt, where we are going to learn about the IUPAC nomenclature of coordination compound. Here we are in the Manocha Academy discussing this topic. Please log into our website and check our website for the different courses that we have, the classes that we run, class 8 to class 12, and the different courses that we have. You can check for the details once you move into our website. So, we start with today's class. So, here, how do we name compounds? Okay, many things are written, but certain things I already told you. So, let me have a look here. First of all, when we name a compound, ionic compound, it's also ionic type only, you are having a cation part, anion part. You name as sodium chloride, magnesium oxide, that means you are naming the cation first and then you are naming the anion. So, here also the first rule is, first you are naming the cation, then the anion. Like I said, potassium ferrocyanide. So, there potassium is the cation part, ferrocyanide is the anion part. Potassium is the ionization sphere part or the counter ion part, ferrocyanide becomes the coordination sphere part, which is the anionic part. So, first you name the cation, then the anion, as we name any inorganic compound. That is the first rule. So, you see here, cation comes first, followed by the anion. Then, listing sequence is, how do we name it? We come to it. We name the, how do we name it? What do we have in the coordination compound? We have a metal atom or the ion. That is metal, it's having an oxidation state. You have ligand, you have a counter ion, right? Now, whether you are naming the cation then the anion, but then how do you are naming the coordination sphere? How do you are naming it? The order is, first comes the ligand, then comes the metal. After you write the metal, inside the bracket, inside the parenthesis, you write the oxidation number in Roman numeral. Okay, you will understand this much better as we move with the examples, not to worry. Now, this part we have done. How do you name the ligands? See, how do you name the anionic ligands? Okay, now if the anionic ligand ends with IDE, like chloride, we end with O. Chloride becomes chlorido, cyanide becomes cyanido, iodide becomes iodido, right? We have done this. ITE, again ITE becomes ito, so ending with ito. Nitride becomes nitrito, sulfide becomes sulfito. Okay. Next, if it's 8, we end with ato. Sulfate, sulfato, oxalate, oxalato, acetate, acetato. Okay. Now, neutral molecule ligand, we have modified names like we discussed, like water is aqua, NH3 is ammine, AMMI, then NO, nitrosyl, CO, carbonyl. So, they have different names which you have to go through and remember the names. How do you name the ligands? Now, we know the basic sequence. We know first we name the cation, then the anion. But how do we name the coordination sphere? Coordination sphere is having ligand, metal, oxidation number. So, what is the sequence there? First you name the ligand, then the metal. After the metal, in parenthesis within the bracket, you mention the oxidation number in Roman numeral. Now, the question is, in heteroleptic ligand there are different ligands. Then how do you sequence the ligand naming? It's alphabetical order that we generally follow for IUPAC nomenclature. Like if it is ethane 1,2-diamine and chlorido, then obviously C comes before E. So, we name chlorido and then we name ethane 1,2-diamine. So, the next is for ligands we name in the alphabetical order. Next, number of the ligands, how do you name? Like we do dimethyl, trimethyl, tetrachloride in IUPAC, same thing here. Di, tri, tetra, like that we use the prefix. So, in the prefix we generally write mono, di, tri, tetra, penta, hexa and so on. Okay. Now, but if the ligand is a bit complex, we will see that with examples, then instead of mentioning as mono, tri, tetra, we name as bis, tris, tetrakase, pentakase. Okay. So, like this we name when the ligand is a bit complex, like ethane 1,2-diamine. Like for example, if it is ethane 1,2-diamine, this amine is amine because we know it's an organic amine. Okay. Suppose if it is EN2, we name as bis, then in bracket we name as ethane 1,2-diamine. Ethane 1,2-diamine. Now, why do we name like this? Of course, there should be a reason behind it. If I write here di, then I write ethane 1,2-diamine. Diethane 1,2-diamine is still can be considered. What about if it is methane amine or if it is methylamine, the one we discussed before, methylamine. If it is dimethylamine whole twice, then if I write as like this, it means something else. But instead of this, we write bis. Then we write methylamine. Suppose I write here cobalt methylamine formula is this CH3NH2 whole twice. More things are there. I am not interested in that right now. If I write this like this and I want a nomenclature, I am writing the IUPAC nomenclature. Instead of this 2, if I write here dimethylamine formula is different, isn't it? Dimethylamine is what? CH3 whole twice NH. When we do organic compound amines, we will understand this better. Dimethylamine's formula is this. Okay, but we are not talking of this. It is actually methylamine, where the number is 2. So it's here, so we don't use dimethylamine. Name becomes completely different. So we use the term bis methylamine. So to form the same protocol, here also we don't write bis. We don't write diethane 1,2-diamine or diethylamine is also different. So we write the word bis. So when the ligand name is a bit complicated, then we use the term bis, tris, like that. Okay. So this is done. Okay. Now we have now examples. Look at the first one. The central metal is nickel. Okay. The central metal is nickel. Now first thing is you have to find the oxidation number also. So we don't know, we take this as X. For 2Cl, it is -2. PPH3 is a neutral ligand. Total charge, nothing is mentioned, means equal to 0. So X becomes equal to +2. So oxidation number is 2. So next, what are the names of the ligand? Cl we know as chlorido. PPH3 is triphenyl phosphine. Phosphine is this, PH3. PH3 is phosphine. 3 hydrogens are replaced by 3 phenyl groups. So it becomes triphenyl phosphine. How many are present? 2 are present. But this is a bit complicated. We can't write di-triphenyl phosphine. How does the name look? So for such thing we use the term bis, tris. Okay. So this is 2. Now, so here it is, the name should start from here. Forget this. I am writing it here. It will become dichlorido. Chlorido. Okay. So alphabetical order, we don't take these, we take the name of the ligand. So dichlorido, then 2 means here bis, within the bracket the complex ligand triphenyl phosphine. After that we name the metal nickel, in the parenthesis the oxidation number in Roman numeral. This is the IUPAC name. The first example, we have many examples. Yes. So oxidation state of the central metal center by Roman numeral, I mentioned this already, in parenthesis. Okay. Okay. If the complex is a cation, then we name as it is. We will do with examples this again. It's better I move with the example part. It will be easier than this. Okay, we will move to examples. Though I have written the name, but I will explain. Now look at this complex. First thing is find the oxidation number. So what we do? Chromium I take as X plus. Ammonia is neutral, water is also neutral. So plus 0. Total charge you can see here, it's 3. Cl means total charge of the coordination sphere is plus 3. So it's plus 3. So oxidation number is X is 3, plus 3. So this ammonia we named as ammine, AMMINE. This water we name as aqua. These are simple ligands. So try, and here also try. Before the ligand, coming to alphabetical order, aqua starts with A and ammine starts with also with A. But then it is, we have to look for the next. We all know all this. Ammine is AM and aqua is AQ. MNOP, so accordingly MNOP QRST. So obviously, so we write here tri, then ammine, then we have tri aqua, name of the metal is chromium, in parenthesis oxidation number is 3, and then here we name as chloride, the counter ion. Now here we don't write trichloride, the counter ion number we don't mention in the name. But if the name is given, how can we walk backwards? You get two type of questions. Either you will be given the molecule or formula and you are told to write the IUPAC name, or you will be told to told the IUPAC name and you have to write the formula. But then you might ask, how do I know how many chloride? Yes, you will be able to. How will you know? From the total charge you will get to know how many Cl are there. Okay. So next one. Here what we have, this whole part if you look to CH2CH, it is En, ethane 1,2-diamine. How many are there? 3 are there. So tris, ethane 1,2-diamine. Only it's a homoleptic ligand, right? So tris, ethane 1,2-diamine. Next you have metal is cobalt. You find the oxidation number. If you find it, you will get the oxidation number is 3. Write that in parenthesis. Then you name the anion here sulfate. Counter ion is sulfate. It's not the ligand here. It's outside the coordination sphere, so it becomes sulfate. Next, this one. Now, this is a bit complicated. Why complicated? You see, this part is the coordination sphere. This part is also a coordination sphere. Okay. Before I do this, I'll do this. Why? You'll get to know better. Now, look here. I'm doing number 4 first. What's the difference of 4 with the 1 and 2 we discussed? In 1 and 2, the coordination sphere was cationic. But in number 4, the coordination sphere is anionic. There is a small change in nomenclature here. If the coordination sphere is anionic, the metal name gets changed. If the coordination sphere is cationic, you name the metal as it is. Like zinc will become zinc only. Cobalt will become cobalt, nickel will be nickel. But if the coordination sphere is anionic, the metal name will end with ATE. Now nickel will be nickelate, zinc will be zincate. Sometimes Latin names are also used, like iron becomes ferrate, silver becomes argentate, gold becomes aurate. Not all, some popular ones. Okay. So you see here, so zinc you see here how it's written, it is ZINC, it's ending with 8. It's a small change here. So if the coordination sphere is anionic, thus all the rules are same, only thing is the metal atom, the metal name you end with ATE. So here you see, first you name the cation, which is the cation here, potassium. How many counter ions we don't mention? So here it is potassium. How many are there? 4 are there. What is OH? Hydroxido. Oxide hydroxido also we told you. So tetra hydroxido. Then the metal you named as zincate, followed by the oxidation number in parenthesis. So now I name here. You have both together. What you have both together? The coordination sphere is cationic. The coordination sphere is also anionic. So you see here how the name is the best example to understand that. First case, Amine is the ligand. How many you have? 2. So it is di. Please look at the spelling of amine. A-M-M-I-N-E. Okay. Diamine. Next the metal becomes silver. Oxidation number, if you find out, it will come to 1. In parenthesis you write. Cationic part done. Coming to anionic part. First part of the naming is same. CN ligand is named as cyanido. How many are there? 2. So dicyanido. Now look, for silver, here the name was silver. For the cationic part, same name. Anionic part, I told you, it ends with ATE. For certain noble ones, Latin name is preferred, or it's used Latin name. So silver is not silverate. It becomes argentate. And then the oxidation number you find out and you write in parenthesis. Only this is the small change. Now come to fifth one, it becomes simpler. Now we'll move a bit faster. Amine, how many? 4. So tetraamine, alphabetical order. Then H2O becomes aqua. So aqua. Cl becomes chlorido. Then you have the metal. Write the metal cobalt. Oxidation number you find out. Write in parenthesis. Counter ion is chloride. You just write chloride. In counter ion we don't mention dichloride, monochloride, whatever it is. Okay. Next. Here again the coordination sphere is anionic. So you look at the name of the metal. Cobalt ends with ATE. Okay. This you have to. So this is mercury cation. Then look here. Another one. New thing. It's an ambidentate ligand where sulfur is the donor atom here. Okay. Though here I have this is the wrong thing written. I am making the correction, please. It is thiocyaneto S. So I am writing it here. Tetra, because 4 are present. Tetra, thio, cyaneto. Okay, ambidentate ligand, but it's bonded with S because it's written as S. If you had written as NCS, then you had written thiocyaneto N. So S is bonding to CO, so the direction is like this. So thiocyaneto, here it will be S, then it will be cobalt. Cobalt obviously 8, anionic coordination sphere, and then you write the oxidation number in parenthesis. Okay. Next. Similarly here, whole is the coordination sphere. Okay. Now, here you have amine, how many? 2. Here you have chlorido, here again ambidentate ligand, it's nitrito, donor atom is N. Now you look at the naming. Diamine, next is chlorido, here you see nitrito N. Ambidentate, next you write the metal which is platinum, oxidation number you find out, it's write in parenthesis. Okay. Next, here the coordination sphere is anionic. This you have to be very careful for the metal. So you start with the cation, which is potassium. So here it is potassium. Now C2O4 2 minus, it is oxalato. Okay. Oxalato means it's a bidentate ligand. I am showing you here oxalate, it's coming from oxalate. You see it's having 2 donor atoms. It's a bidentate ligand. So even here the 3 is mentioned here, the coordination number is not 3, coordination number is 6, or you can say the secondary valence is also equal to 6 because oxalato is a bidentate ligand. Okay. So potassium given, how many are there? 3 are there. So trioxalato. Next here, it's an anionic coordination sphere, so chromium becomes chromate, not the chromate ion. Here it's the chromium in the coordination sphere which is anionic. So the spelling may be same, but it's not chromate, means not CrO4 2 minus. Okay. So it is chromate and then followed by the oxidation number in parenthesis. Okay. Here we'll do this. Here you'll get to know how from the name we write the molecular formula, that I'll explain. Okay, how do we do? First I'll write tetraamine. Tetraamine means I'll write how many amines are there. There are 4. Done. Next, chlorido is mentioned. Now tetraamine, then it's aqua written. That means 1 aqua means 1 water. I have written. Next, Chlorido is written. Only chlorido written means only one Cl. Done. Next, what is the metal? Cobalt. So metal comes here. Done. Now, oxidation number 3 is mentioned. Okay. So I know it is +3. Chloride means outside chloride Cl. But how many Cl I told you we have to find out? How do we find out? You will do with the example. Look here. Now, this charge is +3. Ammonia is neutral, so this is 0. Water is also neutral, so it is 0. Cl we know is anionic ligand with -1 charge, so it is -1. So now what is the total charge we get from here, isn't it? +3 -1. So total charge becomes +2. So if this is +2, then how many Cl should be present to make it equal? Of course, Cl2 must be present, isn't it? So from here we get to know how many chloride are there. I was telling you, but maybe you did not understand, but with the example you will be able to understand. We will do another one example, not to worry, we will do the second example, okay. Potassium tetrahydroxozincate. Now whenever zincate is mentioned, we can understand it's in the coordination sphere is anionic. Not only that, cation name first followed by the anion. So obviously this is the anion. So potassium, I just write K, I will not write the number, that I will write later. Now the coordination sphere begins here. So I put the third bracket. Okay. Now zincate means zinc is there. What are the ligands present? Tetrahydroxo. I told you, you will get it as hydroxo or hydroxido. Nowadays hydroxido is used, that means OH. So it is OH. How many tetra means 4. I close the bracket. Now zinc oxidation number 2 is given here, you can see here. So this is 2 plus each OH is -1. How many OH? Into 4. So what is coming to? It is coming as, this is +2. So +2 minus 4. So it's coming up to what? -2. So if the coordination sphere anionic part is -2, cation will be obviously +2. That means each potassium is +1. That means there should be 2K. So accordingly I write here as 2. This is the way you did. Now did you understand? Next time not doing, you can try on your own. You can take a screenshot and you can try on your own all these 3. I hope you understood this. This is the way we find out the number of counter ion present. From the total charge of the coordination sphere, that total charge will be equal to the ionization sphere total charge. Simple as that. Okay. So this you can do on your own. Next. Okay, the same slide is here, but still I'll show the 5th example. Because I got here one example where it's not a metal ion, it's a metal. See, oxidation number is 0. So we'll do this. Tetracarbonyl. Carbonyl is CO. Okay. Tetra means whole 4. What is the metal? Nickel. So it's nickel. It's the coordination sphere. That's it. So here you see tetranickel carbonyl. Here it's not metal ion, it's the metal when nickel is in 0 oxidation state. Okay. Okay. Here also you will do on your own. I have written self-assessment for all, but I'll do the last one. I'll just show again. Just like that, randomly I choose. You please try on your own. I actually like this part. It's certain things you have to remember, but easy to score, you know. So let's do. See, iron 3, look here. Iron 3 hexacyanoferrate 2. Iron 3 hexacyanate ferrate 2. No, this one I will not do. This one is the toughest of the lot. You do and let me know. Now itself. I'll wait. Okay, before that you do one thing. I give you one easy one to do. Okay, before doing this, you all do number 2 and write. Only few students are there. First do number 2 and let me know in the chat line. See, hexacyano. Nowadays name cyano is not accepted, though the question might be a bit later. It's cyanido, it should be. So hexacyanido means it is CN6 obviously. And after that ferrate written means Fe has to be in the anionic part. Okay. Now here why it's mentioned Fe3, I'll let you know why it's mentioned like that. Fe here it is 2. 2 mentioned, right? I'm not writing it here. Okay. Fe is 2 mentioned. That means this is 2 plus 2 plus. It is actually minus 1 for each Cn into 6. So it becomes plus 2 minus 6 equal to minus 4, right? And iron 3 means here iron is in the plus 3 state. So to make it equal, it is 4 3s are 12. How do you, it's 3 and it is minus 4. So try this out then, how you get the structure. Per coordination sphere, the charge is equal to plus 2 and minus 6 means it is minus 4. But then for one Fe it is plus 3. Then what will make this to equal? This is 4 and this is 3. So if you multiply 3 with 4 it becomes 12 and 4 with 3 it becomes 12. Simple as that. So naturally this is 3, so this becomes 4 and this total charge is 4 minus 4 means we have to multiply this with 3. So naturally I erase this parts carefully. Yes, now this becomes 3. So now you see why. So why this oxidation number is mentioned? Because or else you will not be able to find out how many counter ions are present. Because we have to equalize the cationic charge and anionic charge. This becomes 4 into 3 12 and this is totally, it was minus 4, so 4 into 3 12. Okay. And this is for you again. Please, we have done many IUPAC name. This is for you to solve. Okay, you will be able to just go through the IUPAC rules once. Once you go to the IUPAC rules, you will be able to write all the names. So try it on your own. Take a screenshot and try it on your own. I'll be keeping these 2 slides in next one. You can match with them. Just you have to remember cation first, then anion. Oxalato, how many? 3. Okay, like that you have to name. With this, we come to end of today's class with coordination compound, IUPAC nomenclature of coordination compounds. So thank you all of you. We meet again with the next subtopic in the next video. Till then, thank you and goodbye. Do take care.